Okay, for these, we're writing them in exponential form. And so what we want to do is we want to write the whatever is being rooted to. Well, first let's write the base. So let's take 27. We're saying 2c, and that is being raised to the fourth power, you can see. And it's being rooted to the, what's that invisible root here? If you don't see a number, it's a 2. So it's being rooted to the second root, and it looks like that. And we can actually simplify that into 2c raised to the 4 over 2 is the same as 2 over 1, or 2. So that's the simplified form of that. And of course, we can then actually distribute that through and say that's the same as 2 squared times c squared, or 4c squared. Let's box that out. Okay. This one, for the next one, we say we've got our base of 8x. We are raising it to the second power, that's the numerator, and we are cube rooting it. That's that. And so we say we can give each piece of it. 8 can get that 2/3, and x can get that 2/3. There's nothing we can do with the x, but with the 8 we can. Watch what we can do with the 8. The 8, you're saying, take 8, and I'll do it below in green. I'm going to simplify this part right now. Let's take 8 raised to the second power, and then cube rooted. 8 to the second power is 64. And if we broke that down, get these marks out of the way, if we broke that down, we would get cube root of 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64. And what does it say? It says every time you see it 3 times, bring it out once. So we bring 1, 2 out, and another 2 out. 2 times 2 is 4, and there's nothing left. So it just becomes 4. So that 8 to the 2/3 power is 4, and then x to the 2/3 power. And we're done with that one. Okay. This one, we say, okay, we are taking 625. Notice that 625 does not have the exponent of 3 on it. Okay, it only has, because this doesn't have parentheses around it like that, so it's not actually also getting that raised to the third power. What it is getting, though, is that fourth root. So we say, okay, well, then we would call the exponent 1 over 4, meaning we're really only rooting it times, and then we've got that y raised to the third power, because you can see that that's true. It's inside that y does have the third power on it. And it's also under the fourth root symbol, so it's to the fourth root. Okay, what does that equal? Well, 625 to the 1/4. We did this earlier. If you fourth root 625, what you're really doing is fourth rooting 5 times 5 times 5 times 5, because that makes 625. Okay, so then remember, anytime you see something 4 times, you can bring it outside once, and so all those 5s come out as a single 5, and there's nothing left. So that 625 to the 1/4 power just becomes a 5, and then of course the y to the 3/4 power. Typically, it's easier to simplify, like you're going to be able to simplify numbers when you raise it to some kind of exponent, because you can expand those out into their prime factorizations and bring stuff out. But the y to the 3/4, there's not really anything we can do about that. They want it written in exponential form, not with a radical symbol like it was given to us. So that's our answer for this one. And finally, how are we going to write this as a root? Well, we've got the base of x. It's raised to the third power, and it is fourth rooted. There's no number that we can sort out. That's all that it is. So, and let me just check here against our answers just to verify. 4c squared for 27, 4x to the 2/3 for 29, 31 is 5y to the 3/4, and 33 is x to the 3/4. We're good.